we are getting started on our next presentation. Next up is John Lewis presenting about a manageability test fixture. John Lewis is our test fixture creator extraordinaire, very generous and talented. He's created most of our test fixtures, so he'll share more about his latest here.
Thanks, April. I appreciate that. And welcome back to the NIC Mez stream. Again, my name is John Lewis. I'm a distinguished engineer at Dell EMC, and we're going to talk about a project we call Xavier, and it's an OCP NIC 3.0 systems management validation fixture. When we, well into the NIC 3.0 specification writing, we really determined as a group that we wanted to be able to test all of the interfaces on the board. We had already begun the SI test fixtures. We had talked about a mechanical test fixture, which I believe Chris is presenting in this track today on the mechanical test fixture. Intel provided a shock and vibe test fixture, but something glaring that was missing was a systems management fixture. And so we agreed to give this a shot, and with the community support, we've come up with a card that we call Xavier. And you'll see that we can use it in conjunction with other cards to enable a full set of systems management features. So Xavier includes the ability to functionally validate the following interfaces: NCSI RBT, SM bus, USB, the scan chain, and the bifurcation handshaking with the host. The caveat is that the full bifurcation validation, it's available when you're coupled to a PCIe switch card, which we call Magneto. And that card is also in development, but not a part of this discussion. However, we're certainly happy to discuss it at any time if you're interested. It does connect the Xavier to a PCIe switch to allow the bifurcation to actually negotiate link. So from a block diagram, we're using a microchip, SAM D21 microcontroller. It's the same chip that's used on the thermal test fixture, which Jonathan and I gave a demonstration at the OCP summit back in the spring. And so we're trying to, again, use that way the software that's been made available also works on the Xavier board. We have a few other obvious additions, including a power connector. So we're using the ATX power connector. Again, from the thermal test fixture, we have an NCSI traffic port that simply connects the OCP 3-slot RBT bus through a 100 base T-PHY and allows you to go off to a computer where you can send both positive and negative information. We have a console port on a USB-C port. We have the OCP USB port on a micro USB-B connector. And then we have voltage and current test points and an expansion port for a large form factor. So the card we're looking at here, Xavier, is for small form factors. And this is a picture of it. It also serves as an interposer card, so that if you needed the ability to debug in the system, you could source up to 75 watts or whatever your system would supply through the PCIe edge fingers and run the full OCP card. The software on the card can control all of the key signals to the OCP, including aux and main power enable, the bifurcation and presence signals. And you also have configuration switches and the ability to do that without the software running. and the two dip switches you see on there, the OCP config switches and the clock config switches. We have the ability to reprogram the MCU. So we have a heartbeat LED, we have a UART for debug, and then we have the recommended microchip in-circuit emulation programming header, as well as a reset switch. You don't have to reset your system under test to do that. It'll just reset the microcontroller. We have a large form factor expansion port that hasn't been completed yet, but the work is ongoing at Dell, and we will be contributing that to OCP as soon as that's done. We have test headers for scan chain. We have temperature sensor headers for the different temperature sensors. We can do arbitration in and out test access, so you can look at timing for the arbitration, or you could link these together to two of these cards so that you could test the ability to run traffic simultaneously to two, but only have one talk at once. And then we can measure power shunt, so you can take the actual power of the card in different operational states. These were the key items that the NIC group came up with, and let's take a look at each one. So the general test setup, you have an ATX power supply that connects in, and this is in case you do not have a server. So this can run standalone on a board, on a desk, excuse me, and you can connect via USB for control and Ethernet to the NCSI. The Ethernet port is used strictly for NCSI RBT. It has a PHY on there that emulates the RBT bus, closing the timing loop on the card, so you can run this, a good distance if you needed to. When you're powered, you can through the tower, you can use the shunt test points to collect measurement. The USB connection allows you to do SM bus testing, or you can also connect the SM bus directly to the system if you wanted the server tower or the other another system to test the SM bus. When we talk about NCSI RBT validation, we're talking about functionality testing. We do have test points on the board for you to do timing measurements, but we don't have a way to, for instance, adjust the clock to data relationship. On this board, we deemed that that wasn't something that we wanted to tackle in this first board. At Dell, we have test scripts running on an external computer, and we do positive and negative testing of the OCP NIC. And so we can send the correct and incorrect sequences. We can, using the computer, you can violate the timing of back-to-back packets, etc., and really flesh out any problems with the NCSI RBT interface. So for USB and scan chain, I haven't seen in my lab a small form factor card with a USB connection in it. We did do a test board, and so we have the capability of connecting directly to the OCP NIC. And it's just a micro B connection, and allows you to connect to any of the validation equipment that you want. If you wanted to do compliance testing using an external piece of test equipment, or you can connect to a laptop and just run testing through the laptop. For scan chain, you can read and control the scan chain through the user interface on the micro, and you can also validate the scan chain's timing. We provided a 0.1 inch or 2.5 millimeter test header, and that'll allow you to connect to measurement equipment and look at the scan chain timing. And this is important if you are implementing scan chain, and there was some revisions to the scan chain timing in the spec for the latest revision that was posted last week. So one of the key things that that this card does is it actually allows the bifurcation validation. And to do that, we have a second card, Magneto. Magneto has a PCIe switch on it that can be controlled from the micro on Xavier. And through the user interface, you can select what bifurcation mode that you would like to test. The micro can program the switch, and it will perform link training and train to that mode. And you can test to see if the OCP card supports the modes that it indicates from the systems management interface, the FRU, and the bifurcation signals. And we felt this was critical because at the time there were very few multi-host systems available. And this allows that testing outside of a host system that supports multi-host. So I have a fairly short presentation. Call to action here, join the NIC MES subgroup. We continue to deliver updates to the specification. Again, I believe it was revision 1.1 was released last week. The group is still very active. We meet regularly. You can get involved from the mailing list. The wiki is a great place for information. And then if you're interested in the test fixtures that I've shown here, they're available from UNH-IOL, as well as the design packages being available on the OCP site. So we are releasing those, contributing those to OCP, as well as partnering with UNH-IOL to provide a source for the test fixtures for the industry. So at this point, I would like to open it up to any questions that you might have.
Hey, John, I was curious, what frequency do you have the scan chain clock set to? Use the max in the spec or different frequency?
I believe it is set to the max in the spec, and I'm not sure. That's a good question, April. I don't know if that can be adjusted. I have to look. We actually designed this card. Another engineer in my group designed it some time ago, and we've been waiting to actually get that to UNH-IOL for COVID has kind of slowed things down for us.
Sure. Yeah.
Hey, John, this is Robert from Intel. I have a question on the power delivery. Is the power delivery only available from the ATX connector, or can you configure that to source it from the host platform that you plug that into?
You can source it from the host platform as well. And if you look at the block diagram here, you can source it from either location. It's not very clear, but the idea was that we have two sources of power, either the ATX or the PCI chem connector, and then you can measure the power through the shunts before it goes to the load on the OCP3. I mean, one of the concerns is in the FRU information, we do have the ability to display, max power in certain states, and this card would allow you to do that very easily under controlled conditions. And so that's why we added that feature here. Thanks, Robert.
Okay, thanks.
So right now, Magneto has a Gen 5 or Gen 4 switch on it. Are you considering a Gen 5 version at some point?
Oh yes, the hard questions, April. The Magneto card was initially designed to get Gen 4 capability into the thermal test fixture. When you connect the thermal test fixture via cable to pretty much any system, you're out of signal integrity bounds, let's call it. And so Magneto was put in there so that it could redrive the signals and drive the thermal test fixture, because the thermal test fixture really needs the maximum PCI Express host interface that it's going to support to do thermal testing. So Magneto may be in the future, Magneto may be updated for a Gen 5 design. It's questionable though whether you would necessarily need it on Xavier, because really you're testing the bifurcation of the bus, and it won't matter as much that the bifurcation is at Gen 4 instead of Gen 5. So that's certainly something that, you know, we would consider at Dell, of doing a Gen 5 card if the group wanted that done. But I see the main usage model, the thermal test fixtures, instead of the bifurcation setup here.
Okay.
Also, I have a colleague listening in on the track today, and the scan chain frequency is adjustable in the MCU.
Huh, great.
So we can adjust that. So I think we have about 3 minutes left.
Yep, we have about a few minutes left, so I don't see any questions coming in on the chat. So I wasn't sure if anybody on the line had some more live questions.
I guess one of the things that would be great is, now that you know, a wider audience is seeing this, is there something else that we missed in the interfaces, or is there another feature that someone would like to see on the card? Because we are trying to do this for the entire community, and we took all the feedback in from the people that participate in the compliance group at underneath the NIC MES. But certainly feel free to reach out to anyone in the NIC MES group, Damien or April or myself, if you have a feature that you would like to see added, or another fixture that would really benefit the community. We really wanted to create a holistic approach to this, so that we not only provided, well, here's a card spec, but here's how you validate all of the pieces of it. And I think you know, we're well on our way to that today, especially with the systems management board here, the mechanical fixture, the shock and vibe fixture from Intel, and then the signal integrity fixtures for PCIe.
All right. I don't think there are any more questions online. Thank you, John. My name is Thomas Singh. I am a hardware engineer and a spec editor for OCP NIC 3.0. I'll be doing a presentation